In this video, we're going to use the law of cosines to solve oblique triangles. And you use the law of cosines for the cases of side angle side and side side side. And side angle side is when you have two sides and the angle that they form. And side 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 is pretty obvious. It's when you have three sides and you haven't been given any information about the angles. So before we go over the law of cosines, I'd like you to try to solve this triangle using the law of sines. So pause the video and see what happens when you try to do that, and then start the video back up again. So I would first label the triangle. I'll draw a triangle and label. And now that it's labeled, you'll notice that since you don't have one complete ratio, in other words, an angle and its opposite side, here we have angle A but no side A. We have side B and side C but no angles. And so the law of sines does not work for this problem, which means that we're going to have to use the law of cosines. So let's take a look at the law of cosines. There is a proof in the textbook, and you're not responsible for the proof, but it's always a good idea to look and see where a formula came from and where it was derived. And so the law of cosines says this: if A, B, and C are the measures of the angles of a triangle, and lowercase a, b, and c are the lengths of the sides opposite, then the following is true. A squared equals b squared plus c squared minus 2bc cosine A, or b squared equals a squared plus c squared minus 2ac cosine B. And lastly, c squared equals a squared plus b squared minus 2ab cosine C. You will not be responsible for memorizing these, although the more you use them, the easier they are to memorize. I'm more concerned that you know how to apply them. And so we'll start off with this first example. We're going to solve the following using the law of cosines, which is the same example we attempted to solve using the law of sines. So, as always, I think it's a good idea to draw the triangle and label it. So I've labeled the triangle. And so the first thing that we can do is actually find side A. Since we're given angle A, we can see up here that the formula that has angle A in it is a squared equals b squared plus c squared minus 2bc cosine A. So I've written down the formula, and I've also substituted all the values in. B is 20, c is 30. And so it's 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of 60. And this is equal to a squared. And so what we can do is we can either evaluate this right on our calculator. So 20 squared plus 30 squared minus 2 times 20 times 30 cosine of 60, and hit enter, and we get 700. So at this point you could just write down that a squared equals 700, and therefore, so if a squared equals 700, then a equals the square root of 700. Remember, when you're solving an equation of this type and you take the square root of each side, generally you put the plus or minus in, but since we're talking about the length, that has to be positive. So you could type the square root of 700 in your calculator right now, or there's a shortcut here, and I'll show you. Since we've already got the 700 in our calculator, you could just hit the caret key and raise this to the 1/2, or when you raise something to the 1/2 power, that's like the same thing as taking the square root. And so it'll automatically take your last answer. And so we get 26.5 if we round our answer to the nearest tenth. You could have just as easily done second square, x squared, which is square root of 700, and you get the same exact answer. So now we have the value for A, just 26.5, and there's actually no need to use the law of cosines again, because now we have one complete ratio, so we can use the law of sines to find either of the two remaining angles. And actually the best case scenario is to find the smaller of the two. And the reason there is that if we find the smallest angle, it has to be acute, in which case we will not run into any issue with the ambiguous case. Remember, there cannot be more than one obtuse angle in a triangle. So if the smallest angle has to be an acute angle. So we'll use the law of sines. We'll set up, and the smallest angle is the angle opposite the smallest side. Opposite the smallest side. So 20 is the smallest side, which means that B is going to be the smallest angle. So we use the law of sines to solve for angle B. So we set up our law of sines ratios. 26.5 over the sine of 60 degrees equals 20 over the sine of B. So the sine of B would equal 20 times the sine of 60 divided by 26.5. And you'll notice that as we use the law of sines more often, that I'm skipping steps, I'm leaving steps out. And so now we could just evaluate this on our calculator. We know that if the sine of B is equal to this expression right here, then we can just hit second sine on our calculator, second sine, without rewriting the whole problem again. Again, we're just trying to be more efficient as you get more comfortable using the law of sines. Again, my calculator is in degree mode. Divided by 26.5. Close them. Hit enter. And we're rounding angles to the nearest degree. So we've got 40.8, so that'll be 41 degrees for B. So we'll write that in here. We've got 41 degrees. So we found two of the three missing pieces. And obviously the last part here is the easiest. Once you have two angles, it's very easy to find the third. So angle C is equal to 79 degrees. And we've solved the triangle. I'm going to check this on my calculator by using the law of sines ratios. So 26.5 divided by the sine of 60, and then we'll do 20 divided by the sine of 41, and then we'll do 30 divided by the sine of 79. And you can see that all these are very close. We have not only rounded our angles, but we rounded our sides, and so there certainly is some rounding error there. But it certainly seems that we have done this correctly. I'd like you to pause the video and try to solve the following triangle using the method that we just used. Obviously start the video up again once you've completed the problem. Again, really important that you do these problems on your own before you watch the videos. You're really not going to get anything out of it if you just watch my solutions right away. So the first thing you want to do is draw the triangle and fill in the missing pieces, or the pieces that you have. And now our job is to find angles B, C, and side A. And the first thing we can do is find side A, and we'll do that by first writing down the formula for the law of cosines. So we've got the formula, and we have substituted the appropriate values: b squared plus c squared minus 2 times b times c times the cosine of 48 degrees. We're going to enter this in our calculator. 34.9 squared plus 18.5 squared minus 2 times 34.9 times 18.5 times the cosine of 48 degrees. Close them. That's equal to a squared. I feel no need to write that number down because I want to keep as many digits in the calculator as I can so I don't have any rounding error. We shouldn't round until we actually find the value we want. So I'm going to raise that to the 1/2 power. Oops. You can raise it to the 0.5, that would work also. and we'll get the value for A. I'd also like to show you another way of evaluating this, just to show you more features on the calculator and give you a choice. You could do the same thing. We could type in the 34.9 squared plus the 18.2 squared minus 2 times 34.9 times 18.5 times the cosine of 48. Close the parentheses, hit enter. And the other thing I can do if I want is hit second x squared, which is the square root, and then hit second minus sign. And what that'll do is it's actually the answer key. And what it'll do is it'll take the square root of the last value that you have evaluated. And you can see you get the same exact answer. Your other option is to do second square root and type in that whole expression right under the square root. You have to just make sure that you've got all your parentheses written in if you do it that way. Now that we found one side, it's our job to find the last two angles. And the first angle we should find is the one opposite the smallest side, because we want to find the smaller of the two. This way we're guaranteed not to run into the ambiguous case with the law of sines. So we're going to find angle C. So I'll set up my ratio. So we've got 26.2 over the sine of 48 degrees equals 18.5 over the sine of C. The sine of C equals 18.5 times the sine of 48 degrees divided by 26.2. So we know C, and we'll say approximately because we're going to round, is equal to the inverse sine of this expression. So we'll type this in our calculator. Second sine 18.5 times the sine of 48 divided by 26.2. Close that. Hit enter. And we're going to round angles to the nearest degree. So we've got C is approximately equal to 32 degrees. And so now we have almost everything filled out. The last thing to find is B. And B is just equal to 180 minus the 48 minus the 32. So B is equal to 100 degrees. And at this point, I encourage you to double check by using the law of sines. I'm not going to do that in this video. I think you've seen it enough times, but it's really good for your practice to check and see that those ratios give you values that are very close.